Hello everyone! In this video we're going to talk about file output. We've already seen how we can use files to get input from a different location than the user. Now we're going to see how we can get information to a file or a location other than the output screen. We've already taken a look at these file input and output functions, and we've worked with fscanf to get information from files. So in this video, we're going to work with fprintf to put information into a file. And we're going to start with a very simple example. The purpose of this program is just to print a message to an output file. So remember our basics. We can create a file pointer by using the word file in all capital letters, an asterisk for pointer, and then some variable name. Since this one points to an output file, I'm going to call mine OFP for output file pointer. Then we need to assign this pointer a location. So we want it to point to a file. We're going to open an output file. And since it's an output file, we want to open it in write mode. We want to be able to write to the file. So W for write mode. Then we can use the file print format function to print to the file pointed to by the output file pointer some message. And when we're done interacting with the file, we want to make sure that we closed it again. So we're going to close the output file pointer, and then we're ready to see what it looks like. Now if we fail to close a file, there's a chance that the contents will be corrupted and we won't be able to see any of the output. So we're going to make sure that we close it. When we run the program, we're not going to see anything in our run environment because we're not printing anything to the screen. We haven't used the print format function, so nothing shows up here except for the metadata that happens at the end of a program. Instead, we're going to have to go look in the same directory as our program for our output file. So here's output.txt, and if we open that up, we should see the contents of the print format function that we printed to the file. So now let's experiment. If we change this around and we run the program again, it doesn't have the ability to automatically change the output file. Just like if we fail to recompile, it doesn't automatically change the output stream. We have to close the output file and reopen it to see the new output. And here's an interesting point about write mode. Write mode will entirely overwrite the previous file. It said hello, and we replaced it with the smaller message hi. So it completely erased the previous file and put our new message in there. Now I want to do a slightly more complicated example where we have both input files and output files. So here's a new example. This is miles ran. It's set up in the header format, so the first number is how many participants we have for some contest. And each of those following numbers represents how many miles they ran or walked or jogged or what have you. And we're going to make an output file that prints out a statement for each person that person X ran Y miles. So we're going to have both an input file and an output file. I've already copied this input information into our input file so that we have it to use. So in this program, we're going to need two pointers, IFP and OFP. And we'll need a couple of other things. We'll need the number of participants. We'll need a counter for our loop, and we'll need the current value, which represents the number of miles that that participant ran. Then we can open our files. Our input file, we want to open input.txt, and since it's an input file, we want to open it in read mode. We're also going to open OFP. This will be our output file. And since it's an output file, we want to make sure we open it in write mode. Now we're ready to interact with our files. We want to read from the input file the integer that represents the number of participants. So that'll be the number at the top, the 5 participants that we have in our little contest. Then we can set up our loop to run that many times. And for each iteration, we're going to need to read in how many miles they went and also print out that information to the output file. We're going to read in the current value, it's the current number of miles, and then we're going to print to the output file that our participant number X ran Y miles. Then we're going to fill in those pieces of information. Our current participant can be identified by the number I. I starts at 0 and runs to strictly less than the number of participants, so it'll be 0, 1, 2, 3, and 4. When we print that out, we want to add a 1 to that so that we have 1, 2, 3, 4, and 5 instead. And then the number of miles is represented by the current value. And when we've finished processing our files, we want to close both of them. So we're going to pass the input file pointer to fclose, and then we're going to pass the output file pointer to fclose. Let's see our program in action. We're going to build and run. And remember, since we're sending all of our information to the output file, we're not going to see anything in our run window. So we're just going to go ahead and close that. Then we're going to go find our output file. And so now we should see that our output file matches our input file, but with a little bit more context. Our input file just has numbers, 5, 3, 7, 2, and 8. But our output file has the same numbers with more context. Person 1 ran 5 miles, 2, 3, person 3 ran 7, person 4 ran 2, and person 5 ran 8. Now let's try another practice program that will help with the visualization of this information. We would like to replace that statement, person X ran Y miles, with person X followed by some symbol for each mile that they ran. So for example, the first person ran 5 miles, so we would see person 1 and then 5 symbols. And we're going to adjust the code that we already have. So pause the video for a few minutes and try this on your own, and then come back and see my solution. In order to print out a certain number of things, we're going to need to add another loop. So this is going to become a nested loop example. So we're going to add a second counter, J. For each iteration, we want to read in the current number of miles, and we'll still print person X using I plus 1. This part will stay the same. And then, for each mile that they ran, represented by current value, we want to print to the output file a symbol. I'm using asterisk because I think it's easy to see. So we're just going to print for each mile that they ran 1 symbol. And when we're done printing all of their information, we're going to add to the end of that line the new line character. So now we should have a sort of visual chart that shows each person's miles in a kind of bar chart form. So remember, when we run it, we're not going to see anything in our run window. Instead, we need to go to our output file and see that chart that we built. So we should see 1 symbol for each number of miles that they ran. So 5 for person 1, 3 for person 2, 7 for person 3, 2 for 4, and 8 for 5. In our next video, we'll take this one step further by replacing person 1 with actual names for our participants. I'll see you then.